Welcome to the Radio Revenue Podcast. Hello and welcome to The Deep Dive, the show that takes your source material and cuts through the noise to deliver the essential insights you need to be truly well-informed. Today, we're diving deep into the fascinating and, well, rapidly evolving world of robotics. Our mission today is to give you a clear, concise picture of where we stand with robots and, where we're headed. We've pulled insights from comprehensive reports, including Wave Robotics from the Tony Blair Institute for Global Change, and the very latest data from the International Federation of Robotics 2024 reports on both industrial and service robots. Yeah, we're going to explore global trends, identify the leading nations, uncover the real challenges ahead, and ultimately kind of paint a picture of what our future might look like with more robots among us. It's pretty remarkable how long humanity has dreamed of autonomous machines. I mean, you can trace the idea way back to Aristotle, right?
Absolutely. He speculated about machines that could automate tasks, even imagining a future where they might make manual labor and even slavery obsolete.
Which is an incredible thought for that era. Then fast forward to, what, a 1920s play?
That's right, where the term robots was first used for manufactured workers. And of course, science fiction just ran with it.
It really did. So the big question is, how much of that, long-held vision has actually materialized into our daily lives now?
Well, it's a fantastic historical arc because it puts into perspective the incredible speed of what's happening now. We are truly in the midst of the fastest technological and scientific revolution in human history, and robotics is absolutely central to it.
Right.
Consider this. The first true industrial robot, Unimate, was developed for GM factories way back in 1954.
Wow, 1954. That feels like ages ago.
It does, yet it laid the foundation for the rapid, kind of unprecedented advancements we're seeing today. And a huge catalyst, really, is breakthroughs in artificial intelligence.
Okay, AI. That makes sense.
Yeah, so this means we've moved from robots being this, fantastical sci-fi concept to a tangible reality. We're talking self-driving cars, robots harvesting our food, smart machines packing our deliveries.
It's actually happening.
It's no longer just a concept. It's literally shaping the world around us as we speak.
So, okay, from these intriguing historical roots, how has the actual definition of robot evolved?
Yeah.
And where are these modern marvels, actually taking root around the world today? Because I think for a lot of people, the image might still be like C-3PO or something, but the reality seems much broader.
You're absolutely right. The modern robotics landscape is incredibly diverse. We mostly classify them based on application and environment. So first, you've got industrial robots. Think of these as the workhorse's automated, reprogrammable machines, often with multiple arms, specifically for factory settings and industrial automation.
The classic factory robot arm.
Exactly. They've been around since Unimate in '54, mostly in manufacturing and logistics, handling heavy-duty stuff like welding, painting, cutting, assembly, and general handling operations like moving metal castings or packaging goods. But what's truly astonishing here is China's trajectory.
Oh, yeah.
They accounted for a staggering 51% of global industrial robot installations in 2023.
51%.
Wow.
Yeah, massive leap from just 20% a decade earlier in 2013. It really signifies this fundamental shift in global manufacturing.
That's incredible.
Japan, the US, South Korea, Germany are still major players, obviously, but China's scale is just unparalleled right now.
Okay, that 51% number really sticks.
Yeah.
It highlights the speed and, I guess, the competition to automate. So, beyond the factory floor, where else are robots making an impact? Sounds like there's a whole other category.
Precisely. That brings us to service robots. These are different because they're designed to perform useful tasks for humans or equipment, often interacting directly with people or operating in non-industrial places.
Okay.
The International Federation of Robotics splits these into professional service robots and consumer robots.
Right. What's the difference there?
Professional ones usually need trained operators
Okay.
and are used in public or specialized settings. Think cleaning robots in hospitals, delivery bots bringing you packages, maybe even firefighting robots going into dangerous situations.
Okay. Jobs that enhance what humans do or improve
Oh.
safety.
Exactly. They're designed for specific, often quite complex tasks.
And what about the consumer side? The ones we might actually, buy for ourselves.
Right. Consumer robots. We're talking about things that are already becoming pretty commonplace in homes, actually, like domestic floor and window cleaning robots.
The Roombas and their cousins.
Exactly. Or robotic lawnmowers. And increasingly, we're seeing personal care assistants designed to help with mobility or manipulation, maybe for the elderly or disabled.
Bringing more independence.
A whole new level, potentially. And across all these categories, industrial, professional, consumer, What's really driving their versatility and spread is the increasing integration of AI and enhanced autonomy.
There's AI again.
It's unlocking completely new frontiers, allowing robots to operate with a much higher degree of independence and adapt to complex, messy, unpredictable environments, not just the clean factory floor. And new training tools are helping massively. Things like visualization platforms, like Foxglove, or integrated software like Intrinsic, they really streamline getting different bits of hardware and software to work together.
Making it easier to teach them.
Much easier. Crucial for teaching complex physical movements. Think about Google DeepMind's DemonStart. It helps train AI models to understand physical movement better, leading to better real-world performance, like with self-driving cars.
Okay.
Now, a big challenge is still getting enough real-world data to train these physical robots. It's not like text data for LLMs, right? There's just less of it.
Right. You can't just scrape the internet for physical interaction data.
Exactly. But this is where cutting-edge stuff like zero-shot learning comes in. It basically lets robots do tasks they haven't been specifically trained on, using general knowledge.
Like learning on the fly.
Sort of, like how OpenAI's CLIP understands images from text. These methods make it easier to teach robots new things with less specific training data. It helps bridge that data gap.
Okay, that's fascinating. So with this landscape expanding so fast, who are the real leaders? Which countries were pushing the hardest in this robotics race, and what are their strategies?
Yeah, several nations are definitely making massive strides. Japan and South Korea have long been industrial robotics powerhouses, right? Japan's got this really ambitious moonshot R&D program. They're aiming for AI robots that can autonomously learn and act alongside humans by 2050.
That's ambitious.
It is. And it's backed by serious cash, $220 million over 5 years just for that moonshot. And the government put in $930 million into robotics overall in 2022 alone.
Wow.
South Korea is equally committed. Their fourth Intelligent Robot Basic Plan pledges $2.3 billion by 2030. They want to boost domestic production, review regulations, create jobs. About 15,000 of them.
So serious national commitments there. What about Europe?
In Europe, Germany really stands out. They're the EU's leader. They just launched the Robotics Institute Germany in early 2024, focusing heavily on R&D and education, new courses, new degrees, building that skilled workforce.
And the U.S.? We hear a lot about companies like Boston Dynamics.
Definitely. The United States is home to leading companies like Agility Robotics, Tesla, Figure, all pushing towards general-purpose humanoid robots for industrial use. And Boston Dynamics Stretch Robot, the one for warehouses, it's already boosting productivity, sorting packages.
All right, I've seen videos of that. It's pretty impressive.
It is. Although it's worth noting there's some skepticism. Hans-Peter Braunmo, formerly from Google's Robot Project, questioned if Silicon Valley's usual focus on, minimum viable products and maybe a slight aversion to long-term hardware investment will let them win globally against countries with more integrated strategies.
That's an interesting point. Hardware is hard, as they say.
It is. And then, of course, there's China.
Yes. China. They seem to be surging in robotics, too.
Absolutely. China has shown incredibly rapid growth and investment, heavily fueled by their Made in China 2025 strategy.
Right.
They've stated an ambition to mass-produce humanoid robots by 2025 and make them a key economic engine by 2027. That's very soon.
2025 for mass production. That seems incredibly aggressive.
It does seem aggressive to some, yes. But it's backed by a substantial new $1.4 billion robotics fund. Even if the humanoid timeline shifts, their commitment to expanding general robotics is undeniable and having a huge global impact.
Okay. And are there other players we should watch?
Yeah, definitely. Beyond these big ones, we're seeing emerging players like India and Australia publish their own national robotic strategies. It shows this is becoming a truly global focus and competition.
It really does paint this picture of rapid progress, global innovation. It's exciting. But there have to be hurdles, right? What could slow this down or, cause problems? It can't all be smooth sailing.
You've hit the critical question there. While the tech advances quickly, the real bottlenecks for widespread adoption aren't just about the tech itself. One of the biggest is still costs and accessibility.
Right, the price tag.
Exactly. We've seen great progress. The average price of robotic arms nearly halved between 2017 and 2021, down to around $22,600 from $42,000.
That's a big drop.
It is. And LiDAR sensors, those laser radar things robots use to see their costs, have plummeted. But even so, existing robot tech is still expensive. You often need intensive use to make it pay off economically.
So smaller companies might struggle to invest.
Exactly. Smaller firms, SMEs, they find it hard to make that initial investment. Prices need to fall further for really widespread adoption outside of the big players. Then there are the huge jobs and societal impact concerns. Public apprehension is very real.
The robots are taking our jobs, fear.
Precisely. That 2017 poll found 72% of Europeans believe robots steal people's jobs, and 28% in the UK worried their own job could be automated. That fear is widespread. It leads to debates like the robot tax idea Bill Gates floated, though others argue robots can complement humans, not just replace them.
Has anyone actually implemented a robot tax?
Only South Korea, really. They reduced an automation tax credit back in 2018, which is kind of along those lines, but it's a complex debate.
Very complex. And beyond jobs, what about just practical stuff? Safety, as these things move around us more.
Absolutely crucial. Safety and regulations are vital for public trust and just for responsible deployment. We've seen incidents, like with self-driving cars, right? Crashes led to a sharp drop in American trust back in 2018.
Yeah, I remember that.
So high safety standards and sensible, proportionate regulation are key. The UK's Automated Vehicles Act 2024 is a good example, making sure self-driving vehicles meet strict standards and clarifying who's liable, the manufacturer.
That liability question is huge.
It really is. We also see ongoing efforts in drone regulation, especially for flying them beyond visual line of sight. And overall, there's a huge need for better security safeguards, preventing misuse, protecting user data, especially as robots collect more info about our surroundings.
So these aren't just tech problems, they're really societal challenges.
Exactly. They require very careful navigation.
So given these hurdles, cost, jobs, safety, what does this all mean for the future? How do we get past these? And what's the next big thing we can expect? It feels like we're at a real turning point.
We truly are at an exciting threshold. Solutions are emerging. One of the most anticipated developments, and maybe a solution to some of this, is the rise of general-purpose humanoid robots.
Humanoids, like walking, talking robots.
Well, maybe not talking much initially, but yes, human-shaped robots designed for versatility. Goldman Sachs predicts the global market could hit $38 billion by 2035, selling 1.4 million units a year.
That's massive. What's driving that?
Falling hardware costs, mainly, and those big AI advances we talked about, their research suggests humanoids could actually be economically viable for factories pretty soon, maybe between 2024 and 2027.
That's soon.
And for service sectors between 2028 and 2031. This potential for them to enter factories and services relatively soon directly tackles that cost barrier.
Yeah.
As production scales up and AI makes them more adaptable, the economics just get better.
Making them accessible to more businesses.
Exactly. And eventually, maybe even households. Imagine this. Some studies suggest within the next decade, humanoids could potentially take on up to 40% of typical household chores.
40%, wow. Like cooking and cleaning.
Significant time savings projected in those areas, yes. And this ties back perfectly to how AI-driven adaptability is just transforming the field. AI makes robots incredibly versatile, able to adapt to messy real-world environments, not just sterile factories. Alex Kendall from Wave put it perfectly, I think. He said, 20 years from now, if you ask someone about AI, most people will associate it with physical robots that enhance their lives.
So it becomes less about efficiency in a factory and more about helpful companions.
Enhancing our lives, yeah. Learning, evolving in real time.
So it sounds less like it's humans versus robots then, and more towards collaboration, especially thinking about those societal concerns, like jobs and aging populations.
Precisely. The dynamic is really shifting from just pure competition or replacement to collaboration and complementary roles. Robotics offers powerful solutions for demographic challenges, aging populations, labor shortages. Robots can complement or, yes, sometimes replace human workers in specific roles, often the undesirable ones.
Okay, so that addresses the jobs concern differently.
Yeah, by having robots take on dangerous, repetitive, physically demanding tasks, they don't just replace people, they arguably elevate human work, allowing us to focus on roles needing creativity, empathy, complex problem solving.
Freeing people up for more human-centric work.
Exactly. Think about automating dangerous tasks, reducing injuries, reducing the physical toll that keeps people out of work. Or self-driving vehicles, human error causes, 88% of road collisions?
An incredible statistic.
Automation there has huge potential to save lives and reduce injuries. And think about robotaxis improving mobility and reducing costs for the elderly or disabled. It really points towards profound societal benefits.
A future of collaboration, enabling new kinds of human flourishing?
That's the optimistic view, yes, and one that seems increasingly plausible.
Okay, let's try and bring this deep dive home then.
Well, what we've really explored today highlights this rapid, almost startling evolution of robotics, from those established industrial robots changing manufacturing to this burgeoning world of professional and consumer service robots really starting to integrate into our daily lives. These machines are transforming, well, pretty much every facet of our world.
Hmm.
We've seen how leading nations are strategically investing, innovating, really pushing the limits, especially by integrating advanced AI. But crucially, we also have to acknowledge the real challenges, managing costs for wider access, addressing those public concerns about jobs and ethics, and setting up robust safety standards and regulations to build and keep
The
trust.
balancing act.
It absolutely is. The implications here go way beyond just efficiency, though. These technologies are actively shaping the future of society, economies, our daily lives, in ways we're only just starting to fully understand. Nations that really embrace this strategically, that invest wisely, they stand to gain huge economic and geopolitical benefits. They'll be the leaders in this new era.
And those that lag behind
Yeah.
risk,
Yeah.
well, being left behind.
Risk being left behind in shaping the future of this pivotal technology. Absolutely. So maybe the final thought is this. As robots become more and more integrated into our homes, our workplaces, how will our relationship with them evolve beyond just seeing them as tools? And what new forms of human flourishing might actually emerge from this coexistence as we delegate more and more to our intelligent mechanical partners? It's definitely something for all of us to think about.
It certainly is a fascinating look at where we are and where we might be going. It was a Revenue Radio podcast. Thank you for watching. Please like, subscribe, and hit the bell to stay updated with our latest analyses.